Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into a fascinating topic: operating system generation. Sheila, are you ready to explore how operating systems are tailored for specific hardware configurations?
Absolutely, Victor. This is a crucial aspect of operating system design that many people might not be familiar with. Let's start by explaining what operating system generation actually means.
Great idea, Sheila. Operating system generation, often referred to as system generation or sysgen, is the process of creating a specific version of an operating system for a particular computer installation. It's like customizing a car to fit your exact needs and preferences.
That's a great analogy, Victor. Just as you might choose different features when buying a car, system administrators can select various options and parameters when generating an operating system for their specific hardware configuration.
Exactly. Now let's talk about the sysgen program. This is a special utility that's used to generate the operating system. It reads a description of the specific system from a file, or interactively asks the system administrator questions about the particular hardware and system options desired.
That's interesting, Victor. So, it's like a guided setup process. Can you give us an example of the kind of information the sysgen program might request?
Certainly. The sysgen program might ask about the CPU type, the amount of memory available, the types of I/O devices, and the specific device drivers needed. It could also inquire about system features like the maximum number of processes to support or the types of file systems to include.
I see. So once all this information is collected, what happens next?
Great question, Sheila. The sysgen program uses this information to generate data structures and tables that will be used by the operating system. It might also modify or replace certain modules of the operating system to better suit the specific configuration.
That sounds like a very flexible approach. It reminds me of how modern operating systems like Linux or Windows have a modular design, allowing users to add or remove features as needed.
You're absolutely right, Sheila. This modular approach is a key aspect of modern operating system design. It allows for greater flexibility and efficiency. Instead of having one monolithic system that includes every possible feature, the OS can be tailored to include only what's necessary for a particular installation.
That makes a lot of sense, Victor. It's like having a custom-built computer instead of a one-size-fits-all model. But I'm curious, how does this process affect system performance?
That's an excellent point to bring up, Sheila. The generation process allows for tuning system performance. By selecting only the necessary components and optimizing parameters for the specific hardware, the resulting operating system can be more efficient than a generic version.
I can see how that would be beneficial. Are there any downsides or challenges to this approach?
Well, one potential challenge is that it requires more expertise from system administrators. They need to understand the hardware capabilities and the system requirements to make informed decisions during the generation process. Also, if the hardware configuration changes significantly, the OS might need to be regenerated.
That makes sense. It's a trade-off between customization and simplicity. Victor, how has this process evolved over time? Are modern operating systems still generated this way?
Great question, Sheila. While the concept of system generation is still relevant, the process has evolved significantly. Modern operating systems often use a more dynamic approach. Instead of generating a static system, they use boot time or runtime configuration to adapt to the hardware.
So it's become more automatic and user-friendly.
Exactly. Many modern systems can detect hardware and load appropriate drivers automatically. However, the principles we've discussed are still important. System administrators often need to fine-tune configurations for optimal performance, especially in specialized environments like high-performance computing or embedded systems.
That's fascinating, Victor. It's clear that understanding operating system generation is crucial for anyone working with computer systems, especially in more specialized fields. Can you recap the main points we've covered today?
Certainly, Sheila. We've learned that operating system generation, or sysgen, is the process of creating a tailored version of an OS for specific hardware. We discussed the sysgen program, which collects information about the system configuration. We explored how this process allows for a modular approach to OS design, enabling greater flexibility and efficiency. We also touched on how this concept has evolved in modern systems, moving towards more dynamic configuration methods.
Thank you, Victor. This has been a really informative discussion about operating system generation. I'm sure our listeners have gained valuable insights into this important aspect of OS design and implementation.
Thank you, Sheila, and thanks to all our listeners for tuning in. Until next time, keep exploring the fascinating world of operating systems.